products. John, are you ready for this? I didn't think so. Yeah, you gotta learn your oxidation states. Okay, Liam, would you do our reactants, oxidation states? And Patrick, would you do our products, oxidation states? We have some Happy Steeler fans in here. Figured. I didn't get to see that hit. Who was the dude who got hit like crazy? Moore, and he plays for Dolphins?
Yeah.
I'm gonna look it up. Oh, okay. Okay. Because I like had the game on, but I was like kind of distracted. Actually, I was in the shower when we hit real hard, and like 15 minutes after one play, and then the announcers are like, I don't know if he's all together with it. He loves it.
He said he was unconscious for less than a second.
Was it a clean hit?
Yeah.
It was clean. There was nothing.
It was just wing tackle, top of a Caprice helmet slammed into him. And so basically lifted up and twisted.
I'm gonna look at it because I'm sure that you can find that anywhere now. Hit like that. Be careful there, man. So you're gonna add up to, you got -2, right? So how many does that add up to with the 4 of them? -8. So you're gonna have a surplus of negatives because you have -1 as overall. So your positives must be smaller than your negatives. Yeah. If it was +6, then that would be a -2. You got -8. Well, if it was +8, it would be neutral.
But it has to equal negative.
It has to equal negative. Good. That's right. Okay, so oxygen has to be in, okay. Okay, by rule, oxygen is a -2 in its substances. If this is -2 and you have 4 of them, then that adds up to -8. Everything between these two must add up to just negative. So these are -8, so this must be +7. +7 minus 8 gives you -1. Monoatomic ions are equal to their charge, so this has an oxidation state of -2. This one, again, is a little tricky, but this is a metal, non-metal. And if this is a metal, non-metal, then this has to have its charge that it was associated with its group 16, or -2, just like this is -2. Manganese must be +2 then, because if that's -2, that's +2. And this sulfur, that's got to be 0 because it's elemental. All right, next two guys identify Carson, the oxidation reaction, and Joe DeMarco identified the reduction reaction. So Carson's got oxidation, Joe's got reduction. So remember this, we're just going to circle and connect. We both got it? Okay. So I'm just going to give you a little word to the wise, a little hint. One of the things that's weird about this problem is, do you notice that there's sulfur in the oxidation reaction? Both things are sulfur. That's not weird. But there's also sulfur in the reduction reaction. You see that? So just keep this in mind. Whoever gets up there and balance elements other than hydrogen and oxygen, if you have to bring in an element and it's not on one side of the equation, you probably should bring in something that's in the equation if possible. And you'll see what I mean when we get there in a second. That didn't make sense? Don't worry. But it'll make sense when you see it. It's just a hint. Okay, so Jarrell, would you write out our oxidation reaction? And Gary, would you write out our reduction reaction? Remember, we're going to want to be mindful of space because we're going to be working down for a while, right? So we probably want to nestle up as high as we can to the trough. Now be careful there, Jarrell, because you're going to run right into the stuff that's already written there. So what I'm saying is that you might want to work in a line starting like about here. You get what I'm saying? So we'll be underneath all that stuff that's already written. Good? the next step after you separate? Balance. Gentlemen, everything?
But hydrogen and oxygen.
Okay, now, will you do that for the first one, please?
You don't have to.
You don't have to, right? So you balance elements other than hydrogen and oxygen, in this one, there's nothing to do. Okay? Here at height, will you do it for the second one? Here's where my little hint comes into play. So Garrett, what is out of balance that's not hydrogen and oxygen?
Let's say sulfur.
Sulfur, right? So you're gonna need some sulfur on this side, right?
Yep.
You know what kind of sulfur you're gonna bring in? That kind.
That kind of sulfur.
Because do you see how it's already on the reactant side?
Mhm.
So when you balance up that S, don't balance it with just an S, balance it with S negative 2. Does everybody see that?
Yeah.
That's one of those tricks that come up where you just gotta say, oh, it's already there. We know it's there. So that's where it's gonna balance.
That's just right up there.
I would rather add a new step. Yeah, I like that because then we can see the change each step. Chris Malik, what's the next thing you do after balancing all elements of hydrogen and oxygen?
That's a good question.
Okay.
Balance oxygen using H2O.
Okay, balance oxygen using H2O. Will you do that for the first one? You're good, right? There's nothing to do. Okay. Tyler, will you do that for the second one? Balance oxygen using water. Excellent. So that balances up our oxygens. So we have 4 oxygens on each side. Okay, Rob Harris, what's the next thing you do after balancing oxygen using water?
You balance hydrogen using H+.
Okay, will you do that for the first one? Nothing to do. Okay. All right. Trent, would you balance up our hydrogens using H plus in our second reduction reaction? That's and next year, what do you think, Tyler? Better chance next year, but winning states and wrestling is not. Because we beat AAA, and we're like one of the smallest schools in AAA. You know, we're competing against schools like Cumberland Valley and Nazareth. And plus too, like, you know how here, like, the athletes play football and a lot of athletes play basketball and stuff. Like some of these schools, like wrestling is the stuff. Like they have like radio broadcasts, they do cover live. So like it's pretty competitive here. You know? Like what would you say is the best state for football? Like Texas, Pennsylvania's out for wrestling.
Wait, do you have?
So I'd like to see us place. I think we can place maybe this year or next year. You know, like top 4 would be nice. I love it. Believe me, I love it. It's not outside, but the thing is too is, you know, like let's say in football, you get an injury, right? Well, you fill a guy in. Here, if we get one injury, that can ruin the whole team's chances. You know what I mean? Because now, getting an injury, say you get an injury to say Tyler can go from somebody who earned the team 6 points to being that we give up 6 points. That's a 12-point swing.
I'm stuck.
We still need the 4H2O. You can't change that.
Yeah.
You just got a copy. And you're balancing up H's. You don't know if you need to add anything there yet. Let's get rid of that plus sign. How many H's do you have on the left?
4 or 8
Nope.
or 11. You don't have any. So you have to add 4.
Yep. Not 4.
8.
8. Good job. Okay, so now we had 4H2O on the right, so we brought in 8H plus over here. Okay, don't get me wrong. I would love to live, but I don't want to talk smack. You know what I mean? Okay, so Adam, since this is in a basic solution, what do we got to do now? What was that again?
idea.
Okay, so let's look at our notes from Friday. It says in the basic solution, after adding H plus,
It says after adding eight, we have to add the same number of OHs
add the same number of OHs to
each side.
each side of the equation. Okay, so would you do that for us? Now again, you can do it any way you want. I like to write my 8 OHs under here and circle it so I remember that that's going to become 8 waters, and then I'm going to bring in 8 OHs on the other side. Good. Okay, race. After we do that, what do we do next?
Balance out the electrons.
Okay, so we do that for the first one. And Matt Berry, we do it for the second one. And here's a hint, Matt, and I know you probably know this, but when I do this next line, what I do is first I just rewrite the line by making that thing that races in front of the 8H plus 8OH. I make that 8H2O, and then I worry about charge. Because then I get that in my head that that's not a charge anymore. So we're going to write this 8H2O, and then copy everything down, and then figure out what our electron needs is. Race added 2 electrons here to make this side 2 negatives, just like that's 2 negatives. So that turned H plus and 8OH into 8H2O, and now it's copying everything else. And then you can look at the charge and figure out what he's got to do. Okay, so now it's charged. Right. So he added 5 electrons to the reactant side. Because on the right side, or the product side of his reduction reaction, he has 8 negatives here. No charge, no charge. 8. So here's one of those negatives. Here's 2 more of those negatives. So there's 3 negatives here. We still need to get to -8. 5 more brings us to -8. Okay, next. Nick Wetzel. Nick, what happens next? Now we have a problem we got to reconcile. What is that?
Don't we bring down the oxidation and cancel?
No, before that. If I dropped a $20 bill out in the parking lot, what's somebody going to find?
Oh, we have to make them even.
Okay, so what do you think's going to make them even?
Probably times this side by 2 and times that side by 5.
Okay, so we do the one, maybe you do whichever one you want. And then Michael Bevan, will you do the other one? So we're going to bring them up to 10 electrons. Question? Comment?
Yeah. So a polyatomic ion, we just keep it a pure thing without a coefficient stuff charge. You wouldn't say-
You can, yeah.
Okay.
But they'd still have individual oxidation states.
Yeah, potentially. Is that right?
That looks good to me. 5s, -2, 5s, 10 electrons. Good. Okay, now what I would probably do is I would still probably bring you're good. I would probably bring this equation down under this one because I still have room. If space became an issue, there's no reason why I couldn't rewrite this up here, right? But I don't want to write all that, so I'd rather write less. So John Lupo, will you set up our addition by bringing this down under this guy? And what do we want to line up here? The arrows, yeah. Yes. Oh,
Going off of Dave's question earlier, if the electrons are on the same side, how far back would you have to look to see where you messed up?
You have to start back at the beginning.
That's why I say you do each step each time. Because what I would do is I would start at the beginning and just start going out through my steps to see if I made a mistake. If you just kept writing things like bing, 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 like this instead of building down, you never got it. But you still have to go back to the beginning, but here you can go through the order that you did things. actually do the add, what would you want to do?
Cancel.
So why don't you cancel as many things as you see that you can cancel right now? Electrons have to go, right? That's a must. All 8 waters go, leaving 8 on the grid.
Or that.
Yeah, I see what you did, but it's an addition, subtraction kind of deal, right? So how many left? Take away 8. 8, good. One more thing. No, I'll take it back. I don't see one more. I thought I did.
So these two things, we just subtract, not
Yep.
divide.
Correct.
That's my loss.
Andy Burns, special appearance. You've been at the bottom of the deck lately, man. See, it comes around and goes around. You want to tell us what that all adds up to? Who's getting off the hook today? Careful there. Careful there. Andy, careful there. That's not right. 2s negative 2. That's what's up there. I know. Well, there's more than 2s negative 2.
Oh,